Today we're exploring the surprisingly high stakes involved in drawing, well, what seems like a straight line. Specifically, how apparel professionals communicate the tiny, perfect details of garment assembly to manufacturers.
Hmm.
We are diving into tech packs, the technical blueprints that define whether your new product prototype comes back ready for approval or ready for the trash bin.
The stakes here are truly enormous. I mean, if you are designing a high-end technical garment, maybe a parka or some performance wear, and you fail to specify exactly how, say, the critical shoulder seam is assembled, you basically leave the manufacturer to their own devices.
And their device is the default option, right?
Exactly. You are likely going to receive the industry standard default. And our sources, they actually give us the exact specification for that failure.
Okay, so our mission today isn't just to, cut through the complexity of tech packs. It's really to find the precise, maybe even universal language of assembly that guarantees, hopefully, one sample is all you need to give the green light for production.
That's the goal.
We need to specify the structure, the stitch, the top stitch types, everything exactly.
We absolutely do. And, professionals learn pretty quickly. They need far more than just a general drawing. Our analysis today focuses on the three main resources designers rely on to communicate assembly: text, pictures, and specialized seam sketches.
Okay, let's start with the method that seems, on the surface, quickest to create, but turns out to be the least effective: simple text descriptions.
Right. Text definitely wins on speed and practicality at first glance. It's quick to type up, it's light on database space, takes up very little room on the spec sheet. That's the pro side.
Right.
But those benefits are pretty much immediately canceled out by two major communication hurdles.
Okay, hurdle number one being just simple ambiguity, like calling the seam different things.
Yes, exactly. The name of the seam, even if you're speaking the same language, say English,
Yeah.
it can vary wildly depending on your geographic location or maybe which factory you trained in. That leads instantly to interpretation problems. Big ones.
Okay, and the second hurdle, which feels even more critical when you're working with global suppliers, is the language barrier itself.
Absolutely. The text is usually written in English, right? Which is often not the native language of the factory worker or maybe the local product developer on the ground. So when you try to describe a complex physical structure using potentially ambiguous words in someone's second or third language, well, misunderstandings are almost inevitable.
And translating it doesn't always fix it.
Well, sometimes a product development team tries to solve that by translating the whole tech pack into the factory's native language. But often they've just introduced what our sources call an extra step in the cycle and, frankly, another critical chance for confusion and errors to creep in.
Okay, so text is out because of ambiguity and translation issues. Does the universal language of pictures solve everything then? Let's move to that next level, using photos of the seams.
It feels like it should, doesn't it? Conceptually, anyway. And visually, pictures are certainly more effective than text. They are generally easy to read, easy to understand, and crucially, they seem to eliminate the need for translation.
Seems key. But the source material is pretty quick to highlight that pictures actually introduce a whole host of practical drawbacks, things that make them unreliable for specifying mass production. What's the biggest technical flaw there?
The biggest flaw, I think, is often the incomplete view you get. A photo typically only shows the right face of the seam.
Meaning the outside, what it looks like finished.
Exactly. You see the finished, hopefully perfect outer look, but you completely miss the crucial engineering underneath, how the different plies of fabric are layered and stitched together on the inside.
Ah, so you see the result, but not how they got there, the cause.
Precisely. The actual structure of the seam is unclear. It leaves the assembly method wide open to different interpretations. If the manufacturer can't see that internal structure, well, they have to guess. And guessing leads to errors.
Okay, so incomplete view is a major issue. But setting that aside for a second, what about the logistics? Isn't taking a high-quality photo of a seam still easier than creating some technical diagram?
You'd think so, but not necessarily. Designers often just don't have the exact photo needed for that specific construction they're trying to communicate.
So they use something similar.
Yeah, they end up using a close enough image, which honestly is just as dangerous as using vague text. And then you mentioned logistics. Photos are, well, they're much heavier files than text or diagrams. They increase the tech pack file size significantly.
But storage is cheap these days, right? Why is file size still a major con in the apparel supply chain?
They are being downloaded in factories all around the world where bandwidth can be severely limited. Slow, heavy files mean wasted time for product developers or even dealing with corrupted data.
Hmm.
And even if the file downloads perfectly, the photo itself has to be absolutely perfectly lit, sharply focused, just to even appreciate the fine details. Otherwise, it's pretty much useless.
Okay. So text is too ambiguous, photos are often incomplete, technically a bit burdensome, and slow. That brings us then to the gold standard. The specialized seam sketch is what the pros prefer, apparently.
Yep.
Why does the technical sketch succeed where the other two kind of fall short?
The seamed sketch is really the most professional and specific resource available, mainly because it solves virtually all those problems we just talked about almost instantly.
How so?
Well, like pictures, there's no translation needed. That establishes immediate universal understanding. But unlike text or photos, the sketches are the most specific possible resource. They clearly define the structure, the exact stitch type, and the top stitch configuration. No guesswork.
And they totally solve that critical problem of the incomplete view that we saw with photos.
Yes, absolutely. With a proper seam sketch, you can clearly see both the finished outside and, critically, the internal assembly. How the fabric plies are layered and stitched. That provides complete, unambiguous information to the supplier.
Okay. And practical benefits.
Big ones. They share the best practical advantage of text. Their data size is light, very small files, and they take up relatively little space on the text sheet itself. So easy to send, easy to store.
If they are so specific and practical, what's the main resistance? Why aren't they used universally? What do designers face when they first try to transition to using them?
The main hurdle seems to be initial visualization. It just takes a moment, a bit of practice to learn to interpret the technical diagrams correctly, especially if you are used to just looking at a finished product photo.
Okay, a learning curve.
A small one, yeah. However, what we consistently see in practice and what our sources confirm is that designers quickly overcome this initial designer interpretation challenge. And actually, they often begin to prefer the sketches because they guarantee precision and they're just so practical day to day.
And this isn't just theory, right? We have proof from the source author's own experience. They mentioned using these seam sketches for almost 20 years with suppliers across 5 continents and noted excellent results.
Yeah, that really proves that this specific visual language is universal. It genuinely works everywhere. And there's another fascinating detail in there. Factories often reply back to product developers using seam sketches themselves, maybe to suggest technical changes or improvements.
Oh, interesting. So they adopt the language back.
Exactly. That shows real mutual understanding and, frankly, respect for this specific communication format. It becomes a shared technical language.
And the only potential argument left against the sketch, that maybe drawing one takes longer, that's completely negated if you're using an existing library, a seams gallery, and just copy and paste the precise diagram you need right into the tech pack.
Precisely. Once you have that library of specific assemblies built up, the supposed speed advantage of just typing simple text completely disappears. Copy-paste is fast.
Okay, so if seam sketches are clearly the most effective, the most specific,
Mhm.
should apparel development professionals just ditch text and photos entirely? Just go sketches only on everything?
Well, that raises the core strategic question, doesn't it? And the ultimate takeaway from industry experts, from the people doing this every day, is that the most effective way to explain garment assembly is actually the strategic combination of these 3 resources.
Combination, not replacement.
Exactly, especially when you're dealing with highly complex seams or maybe unusual constructions. The combination is the essential tool, not necessarily the elimination of the others.
Okay, so how should a professional integrate this then? What's the sort of usage strategy? How do you combine them effectively?
Well, the best practice seems to be using the specific seam sketches as the absolute foundation. That's your non-negotiable engineering blueprint that dictates the construction.
Got it. Sketches first.
Then you use text, not really to describe the seam name anymore, but maybe to clarify the overall message or an instruction, like specifically referencing where that particular seam should be placed on the garment pattern piece.
Okay, context for the sketch.
Right. And then you use pictures much more sparingly, perhaps only for those highly complex or maybe really unique seams that genuinely need some extra visualization. Purely for visual context, though, not for the core assembly instruction. The sketch still handles that.
Okay, that makes sense. And the relevance here for you, the listener, the professional doing this work, is the tangible benefit of getting this communication piece right. It directly impacts your development timeline, your budget.
Absolutely. When the construction of a design is clearly explained, when it's unambiguous right from the very start, you just stop receiving prototypes that are riddled with basic assembly errors. obvious mistakes.
Which saves time and money.
Huge amounts. It allows you to focus your valuable time and energy on improving the garment's actual fit, the fabric performance, the design details, instead of just fixing communication mistakes over and over again.
Makes sense.
Ultimately, getting this right helps shorten the entire development process significantly. Our sources note it requires even fewer samples to give the okay for production. And fewer samples means faster to market, lower costs. It's a big win.
That is a really sharp conclusion.
Mm-hmm.
So we've journeyed from recognizing the error of the default to understanding why text is just too geographically ambiguous and translation-prone, and why photos, while visual, often provide incomplete engineering data and have logistical issues.
Right.
We've recognized the undeniable power, the precision, of the specific seam sketch, and landed on the final strategic answer. It's the smart combination of all three resources, but always with the sketch as that unambiguous foundation.
Well put. And if we accept that, if we acknowledge that precise communication really does shorten the sampling process and speeds up production approval, it raises a pretty profound final thought for you, the listener, to chew on.
Okay.
Since every single sample iteration costs time, materials, energy, shipping, labor, how much of the apparel industry's current production waste, its delays, its financial losses, how much of that can be directly traced back to a simple, fundamental failure to correctly specify the assembly of just a single seam in a tech pack? The financial incentive, let alone the environmental incentive, to get this right is just massive.
That's a truly powerful way to frame technical communication. Definitely something to think about. Apply this deep dive knowledge the next time you draft a tech pack or analyze a prototype. Thanks for taking this deep dive with us today.